started. And let me share this. And the question was, why did I do that? Here we go. 75 on 5-1. Oh yeah, I love this problem. Sorry. So a farmer finds that if she plants 75 trees per acre, each tree will yield 20 bushels of fruit. She estimates that for each additional tree planted per acre, the yield of each tree will decrease by 3 bushels. This is a very interesting problem. The least interesting thing is I've done so many of these problems with students, and I've never actually looked up to see how true to life this is. But I think I remember one time seeing one of these problems was sort of true to life. It kind of makes sense. You plant another tree, it takes up resources, and then all the trees that are around it in itself produces a little bit less. But let me see, who asked that question? Do you have a specific question, or do you just need help setting it up?
I don't know how to set it up.
Setting it up, okay. Yeah, this kind of problem is a little bit freakadelic. Oh, crappity do thou. Hold on, everybody. How do I do that now? Oh, can I do it now? No. Oh, you gotta love Jeff just trying, just so trying to come on. Use technology. There we go. All right. Where are we at? Okay. So I really want this. So if I do, so right now, before she does anything, she estimates that if she makes this change, all right, but so how many total bushels, that's hard to say. How many total bushels of fruit, not bullshits, Jeff, how many bushels of fruit will she get total right now? Just to play around with this a little bit.
20.
Yeah, well, each tree will yield 20 bushels of fruit.
Gotcha.
So, I mean, so per acre, so 75 times 20, that's how much she'll make per acre. Is everybody with me? That, what I just did has zero to do with the answer eventually, but it's just me getting a feel for where things are. So right now she can expect that many bushels of fruit. So now watch. And again, let me make sure you guys understand. Well, I'm about to do some work that you don't have to do at all, but just to get a feel for things. So if she planted one additional tree per acre, now it's 76. The yield decreases by 3. So what does this become?
-3.
Well, it doesn't become -3. What does it become?
17.
17. Yeah. -3 would be she has to sacrifice 3 bushels to the ground.
Oh,
or
yeah,
something.
yeah. My bad, yeah.
A little weird. So 75 times 20 is, who knows? What is that? Why can't I do that? I'm tired. 75 times 20.
1,550.
Thank you. And what's 76 times 17?
1,292.
1292?
Yep.
Okay. All right. And if I go the other way, everything I'm doing right now has nothing to do with getting to the answer. So you guys, it's too bad for you. I'm in charge. Oh, thank you, Amber. I like that. Let me see. So if I went the other way and I took a tree away, and assuming that this kind of holds, what would happen to my yield? It would go back up by 3. And what's 74 times 23? Somebody help me out. I mean, I guess I got a 1702. All right, let me stop right now. So what I want to do, now here's where what I just did comes directly into play. Do you know how many trees she's going to want to add or subtract to get the sweet spot? You guys understand this is a sweet spot problem? I don't know. I what do you call it? Emily, that might be true. I crowdsourced that problem. So this could be 1,500. I don't know. Thank you.
It is 1,500.
Okay. So stay with me. So this is do you understand what I mean when I say this is a sweet spot problem? There should be some optimal number of trees per acre so that overall she'll get the most bushels of fruit, right? Okay. So if I start with 75 and I add, how many trees am I going to add? Do we know? To get the sweet spot. That's the whole point of the problem, right? We have no idea. So let me stop for a minute. Is everybody, if I took it and I added one, decreased, I could see what happens. If I subtract one and increase that, I can see what happens. So I know it's probably going to end up being a negative number here. I just want to figure out exactly what it is. So right now, I don't know what the best amount is, do I? So what do I call it?
It's a variable, x.
There you go. I like it. I would have accepted any letter, any symbol. Well, almost any. Let me be careful. And then what happens to, so this is the number of trees. What happens to the bushels? For every tree I put in, what happens to the bushels? You can do it.
It decreases by 3.
Decreases by 3. So what will those be? 20 minus?
7. No, 3.
No.
3x.
Yes. Per tree. How many trees did we put in? X. So how many bushels will I lose? 3 times X. That's why this went down by 3 when I increased by 1, and it went up by 3 when I decreased by 1, because it's 3 times the change in the trees. Let me stop for a minute. So now you see me doing this playing around actually sort of helped me figure out how to set this up. This goes up by 1, this goes down by 3. This goes up by 2, this goes down by 6. So this goes up by x, this goes down by 3x. And that is my function. That is my, I'm going to call it my y of x, my yield function. So how do I maximize the harvest? I make a wicker man. No. How do I
You
maximize?
find the vertex.
Yeah, so now this is quadratic. It doesn't matter that it deals with bushels and trees and acres and shit. It doesn't matter anything. Now I can look at it purely mathematically. It's quadratic. I can multiply this shit out, use the shortcut. Are you guys, is that all right? You guys with me? Maybe? Who asked the question? Was it,
Yeah, I get it.
Amber. No. Amber made the joke. Athena.
Yeah.
Okay. All right. So that's a very classic. Another kind of problem like that is if you sell so many, what was it? If you change the price of a ticket so much, then that means that attendance will change so much. So there's a sweet spot in there. If you make it go up too much, less people will come. If you make it go down too much, you'll get a full arena, but you're not getting much money because you made it so cheap. So there's a sweet spot to hit. And the formula would look so much the same. All right. Any other questions? I'm always concerned where there's not many questions. I'm not sure what to make of that. There are some rather strange questions in the homework. So it's okay to have questions about the homework. Some of it gets a little weird.
I have a question.
Yes.
So for a polynomial, you said that the domain can't be restricted, right? Like one
Now,
of the questions.
any function can have a restricted domain just because of, so if I throw a ball and it moves like a parabola, that's a polynomial. But before I threw it, if I have negative time, I can't let that happen because that's not true. So I can restrict my domain on any function. If somebody just gives me a polynomial, the domain will always be all real numbers. Always. If
Okay.
somebody gives me a rational function, like 1 over x, the domain isn't necessarily all real numbers. It might be restricted by itself. But go ahead, sorry.
So for 5.2, there was a question. It was showing a graph, and it was asking if it was a polynomial, but it had 2 lines, 2 asymptotes on the
Yes,
side.
yes. And I think we actually talked about that one. There you go. That one can't be.
Oh, no, it can't?
Yeah, it's the one that's got the lines. I said it might be some kind of a trigonometric function, right? Let's see, it's number, which one?
I don't recall.
See if I can find it. There it is. The answer to life, the universe, and everything. Number 42. So I want you to realize you are asking a very good question in general. I could totally restrict the domain of a polynomial on my, I could put an extra restriction on it. Is everybody with me? Like I just said. So parabola exists, forever. But if I'm throwing a ball, that parabola starts somewhere and then ends somewhere because of reality. Do you guys see 42 up here? There is no way in hell this is polynomial. There's no way in hell this is somebody restricted to domain, because see how it goes? This is asymptotic. So it goes to infinity right there, right here. Whereas a polynomial function will go to infinity as x goes to infinity. Or, negative infinity or whatever. It's going to go to infinity in both directions, positive or negative. Do you guys see what I'm saying?
Yeah, because the domain will always be negative infinity, right?
Yes, unless the domain has been restricted, which is a really good question, but I can tell 42 is not that situation, because if I restrict the domain of a polynomial, it's just going to sort of stop and stop. It can't go to infinity then, can it?
No.
Because it just eventually, as x gets really big, this one's going to get, will this one make it, all right, let me be careful. I said, will this one make it to infinity? Yes. Right there, it's going to make it there. Even though it can't use any of those x's, it's going to make it to infinity there.
So for problem 9, it's kind of similar, like asking whether it's a polynomial or power function. But because it has the x squared minus 1 in the denominator, that means it's restricted, so it wouldn't be a polynomial?
It's definitely not a polynomial.
Okay.
And the power function that they discuss is very restrictive. It has to be able to be written, where to go? Ax to the, whatever. I wanted to say it the same way the book did, but I forget. Ax to the p, if I remember correctly. Screw it. It's up there somewhere. It's got to be, you must be able to rewrite it as coefficient times x to a power. And there's no way in hell I could do that with this problem. Right? And it's definitely not polynomial. Who knows what you call this kind of function? If you put a number in for x, what kind of number do you get out? If you put 3 in for x, what do you get out?
A fraction.
A fraction, a rational number. So what kind of function is this? A rational function. A rational function. Let me be careful. How you guys doing out there? You okay? I think somebody keeps joining and then dropping. Oh, well. Amber, you okay? What's up?
I'm okay. I'm just letting you know. I'm okay.
Oh, good. All right. Anybody else? And by the way, if I answer a question and it makes you at least as confused as you were before, you got to ask a follow-up question. I got some more chats coming. I think I missed somebody. I'm sorry. Let me go back up. Oh, Melissa, thank you. Oh, I didn't mean to call you out. I'm sorry, but somebody else is asking about number 27. Oh, yeah. Okay, this is beautiful because this is one of the first things I wanted to talk about. Find the intercepts. So the y-intercept is easy for number 27. How do I find the x-intercepts? For number 27, how do I find them?
Factor it.
Factor it, yeah, totally. Right? So, I mean, this one is not allowed to be difficult. It isn't allowed to be difficult. Man, I am an asshole, but it really cannot. This is what I call a thank God problem, or a thank your favorite deity. Thank the spaghetti monster, thank whatever you like, the god of coffee. Because this, does anybody know what the name of this is? What form this is in?
Difference of squares.
Difference of squares. And that is always easy as shit. Always, always, always easy. If you can identify it as being a difference of squares, you just cut everybody in half, plus minus. Cut him in half, cut him in half. Plus minus. Cut 16 in half. And when I say in half, you know, I mean multiplicatively, because we're factoring. Now, am I done there yet?
No.
I really want to blow your mind here. I can factor this one, right? For sure. Is that cool? Because it's just another difference of squares, right? So what do you get?
X plus 2, x minus 2.
Yeah. So let me be really clear right now. If you have a lot of trouble with the problem I'm doing right now, you have got to work on that immediately. Factoring is going to rule our life in so many things in this class. We really need to know how to factor. Now, what I'm about to do, though, might blow some of your minds, but let's see if anybody else remembers or was taught this. I'm going to factor this one, too. And technically, you're not allowed to. But we know certain kinds of numbers that let me do this. Does anybody know how you can factor this?
X plus 2i, x minus 2i.
Kick ass. So the problem with the reason that for real numbers it has to be a negative here is so that these have opposite signs so that the middle term cancels. That's not a negative. Oh shit. There's no real number that when I multiply it by its opposite, I get positive 4. But there is a complex number, an imaginary number, because what is 2i times negative 2i? That's going to be negative 4i squared, right? But what's I squared?
Negative 1.
So you get 4. Kick ass. So then what are my x-intercepts? You can just list them off now. Can you? What are my x-intercepts?
2, negative 2, 2i, negative 2i.
There they are. I just couldn't stop myself. Did the whole problem for you. Damn it. But this is really important. You're going to be doing exactly what I just did a lot. So I don't mind doing that one for you because you're going to be doing it a lot. Okay. So if you really hate that, then your future is not looking good. Sorry. You're going to be factoring a lot. Okay. Is that all right, guys? Is that all right? I don't mean to scare you. Just want to be real. Real talk, kids. All right. Anything else from homework or just general things or anything I've already just discussed that didn't make sense? Oh, man. I lost
I
Brian.
have a question.
Yes.
So is a straight line a polynomial?
Oh, that's a very good question. What kind of straight line?
I don't know, like problem 45, it was asking like what the least degree would be or something, or it was asking if it was a polynomial, but it's a straight
Yeah.
line.
Okay. Yeah. So give me a possible. We don't know anything here, right? But give me just your guess as to what the equation might be for this. Doesn't have to be perfect. It's got a positive slope, right? So we can say y equals x, and then it's got a negative, so maybe minus 4, right? And that's a possibility. Are you with me?
Yes.
Okay. So is that a polynomial function?
Yes.
Yes, good. You're done. I like it. Is this a polynomial function?
No.
Yes.
Yes, it is. Totally. All day long, all day. I got let me see, a private chat. I'll come back to that in a second. I don't know if that's the question we just did. Can somebody give me an example of something that's not a polynomial? Can somebody
Y equals
teach
3.
right? Say again?
Y equals 3.
Nope, that's a polynomial function. That totally is. So stop it. No, that is fine. So what I'm trying to do right now is explain to you in a way why that is a polynomial function.
Oh, I
What
meant
is
X.
Say again, sorry?
I meant X.
Y equals X is a polynomial function.
No,
Just-
like X equals 3.
Oh, okay. So yes, you're right. X equals 3 is not a polynomial function. I like it. It's not even a function though. That's the big problem. Can somebody give me a function that's not a polynomial function? Just give me an expression that's not polynomial.
Could it be
Say
like
again?
y equals 3 to the power of x?
Okay, I like it. Sure. 3 to the x. That's not a polynomial function. I like it. What about x to the negative 2? So this becomes important. What's the definition of a polynomial? And you're all like, I don't know, man. You're the teacher. What the shit? All right. It is an expression made up of terms where all the variables are to whole number powers. Maybe I should write that down. So polynomial, basically, if I want to cut to the chase, get to the heart of the definition, all variables in there have to have all variables and variable expressions must have whole number powers. What are whole numbers?
Zero to infinity.
Good. 0, 1, 2, 3, right? So they're the non-negative integers, 0, 1, 2, 3. So why is this polynomial? Because what's the power on the x?
0.
1.
0.
Oh, 0.
If it was a first power, there would be an x. So how many x's are in the expression 3? There are none. So constants are polynomials by definition. They are basically the most basic polynomial you can have.
And imaginary numbers are also part of that?
You could have polynomials with imaginary coefficients. Yes. Is that what you're asking? That's not
Yes,
really where we
that makes
are.
sense.
We're not anywhere near that. So don't worry. We're not going to do that weird shit yet. We can have complex intercepts like we just saw, right?
Mhm.
Yes, I like it. I like it. Is that all right? You guys okay? You guys all right? No? Okay. I'm going to take this away. Okay. Any other questions that I can just get way too deep with?
So
All right.
4.1
Yes.
and 4.2 is also going to be on this quiz on Monday, correct?
That's right. I like it. So the quiz on Monday, oh yeah, I got to go back to this question I got. Quiz on Monday goes through 401425152. All right, so let me look back. I got a question from somebody, number 27. Is that the one we just did? That is the one we just did. Oh, well then I disagree with their answer. Nah. We can be better. So the real intercepts are 2, 0 and negative 2, 0. But I would argue that we can start talking about complex intercepts also. Because again, so that's unfortunate that the book, I guess the book in the answer key says there's only 2 x-intercepts. Why do we know that to be false? That's okay, Jasmine. I really just want you to understand why I'm going to disagree sometimes with the book. Why do we know this can't have these, oh, definite. These be the only x-intercepts? Why do we, the book can't always be right? Because we're either one of these repeats, where they repeated roots.
No.
So how many roots, and when I say the word roots, are you okay with that? That's another word for the name, for an x-intercept. And the real reason is that if this is the ground, then the x-intercept is where the root starts. So we also call them roots. So why do I know there must be more? And I know exactly that there must be 2 more.
Oh,
How do I know that?
degree.
Say it one more time.
The degree.
Yes, the degree. Exactly. It's a 4th degree is the highest. It's a 4th degree polynomial. It has to have 4 total answers. I like it. We know complex numbers. We know the fundamental theorem of algebra now, because I told you last time. So I want to start using the full picture. I like it. You guys say what?
Can you do another problem like 6 in 4.2? Like something
Let's see.
similar to it?
6 and 4, 2? Let me see. Hold on. Let me get rid of this. Gee, oh, 6. One of our favorites, right? I know. That's the triangle problem, right?
Yeah. Can you just do like another one that's similar to it?
So the idea, let me see if I can do this by just telling you what the idea is. Once you get things drawn out, let me see if I remember. I think it's going to roughly look like this, right? If I remember. If anybody's done that yet. And this is going to be a right angle because it's perpendicular. That's the thing to realize is I need to know that this is a right triangle. That makes it much easier to figure out what the height is. Although you could instead figure out what that height is, and this would be the base. So there's multiple ways to do this. So the whole, I don't know if you got to this point. Did you get to a point where you could actually sketch out what the triangle looks like? Have you gotten to that point yet?
Yeah, I did the whole thing, and I understand it because we did it in class, but I just wanted to do like another problem that's similar, so I know whether I like, really know how to do it or not.
All right, let's see. I mean, they're all basically the same. I mean, the idea to get from these problems is that the most important thing is to find the side lengths, right? Graphing it should be relatively simple. And then you focus on finding the side lengths. Do you understand what I'm saying? I mean, because I have to know the base and the height so I can do the formula. So it really is just, do you remember distance formulas? Really what that problem is. Because the sketching of this should not have been a big deal. And then you just got to identify, what do I need to be able to figure out the area? So it's, I mean, we could do another problem, but I don't see the efficacy of that right now. It's, you either see the idea of sketching the area and then figuring out the side lengths, or you don't. So it's is that all right, Ariana? I'm not getting anything back. What's going on out there? Look, can't always be right. That's right. So, I mean, if you wanted more practice, you certainly could do another problem just like that, like number 7, number 8, right? Because I think I assigned 5 and 6, right? So if you do number 7, you've got the answer you can look at in the back. What was there a part? All right, so maybe I'll just do 7. So if you look at 7, we've got this line. It's bounded by the y-axis now, right? Y-axis. The line f of x equals 9 minus 6, 7. So I know it's got a y-intercept of 9. Is that cool? And then it's got a x-intercept. Where would the x-intercept be for this? It'll be somewhere kind of freaky. You might not even have to worry about it because I'm going to have another line that's perpendicular to this line. So let's just do this. It's going to be over there somewhere. Then I have the line perpendicular to this that goes through the origin. So that sounds very much like this other one. So I'm basically going to have, there's my triangle there. Here's going to be my right angle. Let me stop for a minute. Is everybody cool with that setup so far? All right. What is the equation for the line I just drew? This line here is perpendicular to this line, right? So what's the slope of that new line? Yes. And it goes through the origin, which kicks so much ass, because that's its equation right there. All right, let me stop for a minute. Is everybody cool with what's happened so far? Anybody not cool with what's happened so far? All right, I'm gonna assume that thumbs up is good. Okay. So now I don't worry about that shit. So now if I knew this length and that length, I could do the area of this triangle. And the funny thing is, if you really think about it, if I figure out, so let me give you an optional way to do this. Can you figure out what this x is right there? For that point right there. That's a very important point, right? How would you figure out what that is?
Just set the two equations equal to each other.
Yeah. This line intersects that line. So we'd set this equation equal to that equation. That looks yummy. All right, so I can add 6/7 and blah, 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 whatever the shit that's going to be. Let's see. It's be 7, 6 plus 6/7. So that's 49, 36, 49, 36, 85 over 42. Is that what that is? Is that really what that is? That looks so gross. 49, 36, 85 over 42. Yeah. Crazy. All right. And then I would multiply. This is really gross. 9 times 42 over 85. All right, let me stop for a minute. That's pretty gross. But the funny thing is, I'm not going to do anything with that. I'm not, because I'm going to eventually just throw all this shit in the calculator anyway. Do you guys see what I'm saying? Now watch. Let me, please tell me, if I lost somebody and you haven't said anything, that's a problem. So I haven't really done too much yet. They told me the y-axis is important. They told me this line, and they told me this line. So I have to find out where those lines meet. But do you notice now that I just figured out the height of the triangle if I look at it this way, like this is the base. And that's the height. So therefore I could do 1/2 9 times this thing. Okay, is that all right? Is that all right out there? I forgot who was talking to me. What's the 4.5? I'm sorry. Somebody sent 4.5 to me. Okay. All right, all right. Oh, is the height. Well, is it 9 times 42/85? Is 42/85 reducible? I don't think so. Anyway, I'm not gonna worry. All right. So I'm not hearing anything. I'm gonna assume that was okay.
A question for 5. What does it mean x equals 3?
Yeah, how do I draw that line, x equals 3? What would that look like?
Did you just go straight through 3?
Yeah, in what way?
Up? Vertical?
Okay, I got you. So there's x equals 3, yeah.
Oh, okay, that's it?
The same way that this y-axis acted as one side, the x equals 3 is going to be one side.
Okay.
And they're going to have two other lines come in. You make a triangle out of that.
Got it.
I like it. Some kind of weird geometrical Milan is what I'm going. We'll make a triangle out of that. All right. Okay. So let me clear all that chicken scratch. Any other questions before we move on? Okay. All right, is anybody else able to turn on the camera, by the way? You don't have to, but if a few more people could, I feel like I could retain some of my sanity. No? All right. Thanks, Brian. Okay. So coming back. No more questions? Okay. Let me see. Where do I want to be? Here we go. So let me come back to here real quick. I kind of want to get built up to the point to show you something we're going to use to make something easier to do, some long division. Long division is in our future, believe it or not, but not quite yet. Can you guys do these two problems for me? I don't like this blood red. You would, Jeff. Yeah. All right. So this is just a little walk down memory lane. Can you factor these bad boys? So let me see. What's the first step on this one here?
Would you take out the x squared?
Totally. I love it. So then you're left with what?
X to the 4 minus 3x squared plus 2.
Kick ass. So then this just comes for the ride. And how do I do this guy? This was kind of nice. There's only one way to cut him up. I feel like I'm teaching you all to be your own Dexter. How do you cut this guy up?
Is 2x minus 1.
Not quite. So I agree with this part.
And x squared minus 1?
What was that? So what goes here, sorry?
X squared?
Yes. Because it's x to the 4th. And the middle term is x squared. So real quick, how do I know I can't factor it the way it's given to me? Because that middle dude has to be half of this guy. If that's not true, I can't do it directly into parentheses. That's why I had to take an x squared out first. Now this guy is half of this guy. Why does that make sense? Because I cut this guy in half. And then the middle term is made of the parts of that one. I love it. It's like a Frankenstein thing. All right, and then how do I keep going? Let me see if you guys, can you factor this one? Or maybe you can factor the last one. Let's start with the last. How do you factor this guy? That's easy.
X minus 1, x plus 1.
Yeah, why'd you put 1? That's a really dumb question, but answer it anyway. Why'd you put 1? Why did we put 4 when it was 16 earlier? Because how do you get the number that goes here? You take the square root of this one, right? Are you guys okay with that? I mean, how do I factor this? How do I factor x squared minus 16?
Take the square root and plus or minus.
Yeah, yeah. Like, so,
Well,
yeah. I got you. And so why is that 4? Because the square root of 16 is 4. But an easier way is just say cut it in half, right? That's the way I say it. Cut it in half multiplicatively. But what cuts things in half multiplicatively? The square root. So now you know how to factor this because of that whole tirade I went on. How do I factor this guy?
X minus I rad 2, x plus I rad 2.
Not I, because it's not plus, right? But I do appreciate
yeah.
you trying to be careful. But it's not, if it was plus 2, I would agree with you all day. Now, let me stop for a minute. Please let me know if I am bulldozing you. I don't want to bulldoze you. You're probably not used to doing that, right? But do you see how it only makes sense? And now I barely have to do any work. How do I get all the, what are all the x-intercepts?
Root 2, negative root 2, 1, and negative 1.
You left that poor little dude out.
And 0.
Oh, there we go. Okay, 0, 0, and rad 2. You can do this, plus or minus, and then plus or minus 1, 0. Right? Okay.
Wait. Why 0? Oh, because X. Never mind. Just kidding.
Yeah, good. I like it. If X is 0, it doesn't matter what anybody else is. It all dies. How do I factor this dude? What? Oh, shit, Jeff. Why did you do that? I don't know. Shit up. All right. Let me try it again. How do you factor this guy? There we go. Let's be safe. What version of factoring do I use on this guy? Do we need to have a factoring day? Is that what's happening? Do you guys remember how to factor this guy?
By grouping?
Grouping. I love it. So what comes out of these two?
X squared.
X squared. And what's left?
X minus 5,
Fullness. And what's got to come out of these two?
negative 1.
Good. Because they're all opposite signs of what they're supposed to be. And then, of course, I get
x squared minus 1.
So I can't do this next step unless these are the same. If they're not the same, it makes 0 sense to do something next. That makes no sense. Somebody just throws all the shit down there and prays. No, your prayer will go unanswered. So the thing we just did is we took the x minus 5 out. We can't do that if there's not the same thing. And of course, the last thing I could do is so now I can see my 3x intercepts, negative 1, 0, 1, 0, and 5, 0. Okay, no big deal, right? Is that all right? And it makes sense. There's 3 of them. How many total did we get here? How many total intercepts?
4.
Total.
6.
5.
Yeah, I like it. I would have taken 5. I like the 6 because that's correct. Because how many times did we get this one?
Oh.
Twice. So there are 1, 2, 3, 4, 5, 6. And why does that make sense? Because 6 pound, right? So I know there should be 6 total roots of that. Some of them could be real, some of them could be imaginary, some of them could be radical, right? Irrational. Okay. Maybe. So let me clear that. I'm going to clear it. It's going to go away. Bye. Okay. But you didn't go away. All right. So I want to move to my, my whiteboard. So, I totally killed this guy. Poor little dude. There you go. Yeah. You've had it, haven't you? I'm sorry. Jeez. All right. So, we're about to move into a place where, let me move you guys over here. We're going to have to know how to do certain things. So there's something called, I forgot to do this. Let me spotlight me. Long division of polynomial stuff. Oh, Jeff, let it go. Okay. So if I wanted to do this, do you guys remember doing this at all? Maybe you've blocked it out of your memory. I don't know. Let's do this real quick. Before we do this, let's just remember how long division works. I got a vague, okay. So how would I do this? Sure, I like it. No, let's do this. Sorry. You can do it, Jeff. Sure. I like it. So how do I do this long division? I'm going to do 35 into 7897. Now watch what I'm going to do. 3 goes into 7 twice, so 2 is a good guess there. You see how I can look at the first piece and the first piece and give a good guess as to what to try there? Is everybody with me? You guys with me? All you black boxes with white letters. Okay. And then 2 times 35 is 70. And then what do I do?
Subtract.
That's right. I heard you say change the sign. And then combine. So I get 8. Bring down the 9. I'm almost certain if you would have guessed what we're going to be doing tonight, it wasn't this. So again, 3 goes into 8 twice. 2 times 35 is 70. Change the sign. Combine. Bring down the 7. So here's where things are going to break down a little bit. 3 goes into 19 6 times, so that's going to end up being too much, right? So I'm going to do 5. That'll be 175. Change the sign. I get, what is that? 22. And so then I'm going to put up here plus 22 over 35. All right. That was a trip. So how do I do this? The same damn way I did that. Of course I do. What are variables? They're just numbers I don't know yet. So how are they going to act? Just like numbers do, because that's what the hell they are. So hopefully some of you guys remember doing this long division. So let's see, I'm going to do this. Then I'm going to do like I did just then. I'm going to do exactly what I did. X times what is x squared? X. So x times x is x squared. That's amazing. X times -2 is -2x. Just like I did here, 3 went to 7 twice, but I didn't just do 2 times 3. I did 2 times 3 and 5. Okay. Then what do I do? What do we do over there?
Change the signs.
Change the signs. Kick ass. Combine, bring down the +6. X times what is -2x?
-2.
Negative 2 times x is negative 2x. It's crazy. Negative 2 times negative 2 is plus 4. That's crazy. And then I
Change the signs and combine.
I'm like, you guys are sitting there like, does he really want me to say that? Yes. And then I get, what do I put here now? What's the remainder?
2 over.
2 over x squared. I mean x minus 2.
2 over that, but what's missing? So, I mean, when I write this, what does that really mean? What does this really mean? What's the operation in the middle?
Plusy plus.
Did you say plusy plus? What'd you
Plusy
say?
plus, because I'm an adult. Yes, I
Okay.
say plusy plus.
Yes, so it's a plus, and it's just the worst decision in history is to write it like this because it's the only thing that doesn't mean multiply when it's sitting next to each other. So I really kind of hate that we decided to represent this like that, but that's why that shows up, because this isn't just a number, it's an expression. So I have to put a plus there. I have to. Why does that remainder make sense? Because if that would have been 2 less, that would have went into that directly. Do you guys see that? If that was a 4 there, isn't that what x minus 2 times x minus 2 is? So how much over that was this? It was 2 over that. All right. Okay, maybe. Does anyone know the shortcut to this procedure?
Can't you just divide the x squared and the x like at the top?
Oh, okay. All right. Okay. If I have 16 minus 4 over 16, let's say 4 plus 2, can I just divide those?
No.
No. The appropriate answer is actually hell no. Because division cannot do a damn thing with the subtraction and addition problem. It's not in its wheelhouse, right? That's my hair. I try to cut my hair. Oh. So there's no way in hell I could cancel parts of a subtraction and addition problem. That's not what division can do. How are we doing out there? So you've got to let go of that. You can't start reducing this shit. You cannot. You've got to actively stop yourself from doing that. Okay. We wouldn't do it with that. We can't do it with that. That's why we got to do all this. But let me ask this question again. Has anybody ever heard of the shortcut to this process? Don't you wish there was a shortcut to this? I mean, this is a relatively quick little thing, and look how long that took. Can you imagine if there are more terms up here, which there will be?
You can factor the top part, right?
Nope. I mean, if I could factor, this should have come out to be 0, right? If I could factor and have this cancel. I can't factor the top. There's no multiples of 6. I mean, factors of 6 that add to be -4. All right. So this is interesting. This is interesting. Nobody's heard of this. Okay. There's this really cool method called synthetic division. Are you dying, you poor little dude? You go sleep. Has anybody ever heard of that, synthetic division? Does that sound scary? Does that sound like it's going to be horrible?
No, I've heard of it.
Okay. So, somebody, okay, I get a lot of private chat. Somebody just said, I think you find the smallest the number that goes into the equation, you might be thinking where we're headed eventually. Okay. So now watch this. It's kind of cool. Isn't this kind of annoying, this changing the sign always? And why is there so much shit? Did I really need these? Are these important? Are these right here important? No, they cancel. Who gives a shit about them? What's important is -4, 2, and they make -2 because it told me what to do next. You guys see what I'm saying? So all these variables I keep writing it's just dumb. I just want to know these numbers that lead to these numbers. Okay, maybe. I'm actually not going to do a lot of time trying to prove why this works. I'm going to just show you how to set it up. Because this is really something that most 110 teachers should teach, but I'm not sure how many of you guys took 110 here at Gross One. Watch this. This is so kick-ass. Instead of changing, so I'm going to basically take the variables away, right? And instead of changing the stupid frickin' sign every time, which is easy to forget, I'm going to change it right at the beginning. I'm going to take a -2 and make it become 2. So what that does is it changes the sign once right at the beginning instead of every damn time. Okay, maybe. I've got a handout about this up on Canvas. I just have to make it active. I'm sorry, go ahead.
Don't you pull down on the coefficients?
Yes, good. That's the next step. So I'm taking all the stupid letters out because they just kind of like are a lot to write. So let me write down what are the coefficients involved up here.
-1,
One,
-4, and 6.
-4, and 6.
Good. I like it. So now watch this. This is kind of cool. This is kind of cool. Why did we put a 1 right here? Why did I put 1x there? Let me bring this guy back. Because there's a 1 here. If there would have been a 3 here, what would I have put there?
3x.
3. I would have put a 3 there, exactly. So whatever that first number is going to be the first part of the answer. So I just bring that straight down. And then what do? What's 2 times 1? You see how that's the 1 times 2 that we did? What's 2 times 1?
2.
It's 2. And then I add these. Do you see how we just did this? Do it again. What's 2 times -2? 2 times -2. I'm sorry, here. 2 times -2 is?
-4. -4.
-4. And then you add these. Didn't we just do this? You guys semi with me? Anybody not with me at all? Maybe we should ask it that way.
Can you go over that last step again, please?
Sure, let me see. So are you good up to this point? Bring the 1 down. 2 times 1 is 2. Add. 2 times -2 is -4. Add.
Thank you.
You're welcome. I don't know if that helped. You sounded defeated. Are you okay? All
Yeah,
right.
that makes sense.
Let's do a, and then how do I read the answer? So didn't I effectively just do what Brian was suggesting earlier? Just divide these. I can't do that. But if I do divide this by x, shouldn't the degree of each of these go down by 1? So then how do I read the answer? It started with x squared. So now this is 1x. This is -2. And this is the remainder term. It's 2 over what I was dividing by. So we get the exact same answer. Kick ass. Some caveats to this. It only works directly if the bottom is a linear with a coefficient of 1. That is the only time that synthetic division works directly. There are ways around it, but it sometimes gets disgusting, which you have to do. So let's try one more. Let's try one that's a little bit longer.
Wait, it only works when?
Yeah, it only works if I'm going to divide by x plus a. So here a is -2, right? So it has to be x plus or minus a number. That's the only things I can divide by. And this works directly. If it's not that on the bottom, you can kind of finagle things a little bit, but it gets a little bit freaky. So let's try another one. Let's try another one. See if I can make you work a little bit longer. Poor little dude. All right. Let's see. Let's do. Numbers might get kind of freaky. Good enough. So what's going to go in? So I don't really watch a lot of hockey, but I like to call this the penalty box. What's going to go in the penalty box here?
-1.
-1. I love it. And then of course I'm just going to put now. What would happen? I almost did this, but I figured not yet. But if I was missing a term, do I just skip it here?
You put 0.
You put a 0 there. I love it. Okay. So now I got to have 1, -5, -2, 6, -1. All right. Let me get you going. Go. So you guys take a minute, try to do this one. This is the beauty of this. No matter how long this gets, it's the same thing over and over and over again. It takes relatively little time to do it. Hopefully I didn't make this too freaky. I probably did, didn't I? No, it's not too bad. All right, good. So I'm going to start to catch up with you. So you always bring down whatever the hell that number is, you bring it down. Multiply, add, multiply, add, multiply, add, multiply, add. All right. See, that's the. Have any of you guys ever done something called matrices? Have you guys worked with matrices? Anybody? Emily, you doing okay out there?
I'm good.
Okay. Has anybody ever worked with matrices, with matrix algebra? Nobody? Nobody's ever worked. Yeah, 1, 2, 3, 4. I mean, a little matrix dude. No.
A long time ago.
Yeah.
All right. So it's sort of the same idea with systems of equations. You can just put the coefficients in and leave the variables out. And it just makes the algorithm quicker. So this is very algorithmic. You could program this in a computer and it would just eat it up. So if I made this really long, who gives a shit? That was pretty quick, right? Can you imagine what long division would look like for just this problem? That would be horrendous. That's where you have to tape some paper onto the other paper, you know, just to keep going. So what is my answer though? This would be 1x what?
X cubed.
Good, 1 less. I love it. And then you just keep going less minus 6x squared plus 4x plus 2. And then this guy is going to be the dude that goes over him. So minus 3 over x plus 1. So I want to show you. Here's the last thing we'll do, I think. Maybe not. Let me not say that. First thing I need is something to act like an eraser, because my eraser has exploded. We'll go super high tech. Somebody got what they want from this? I'm going to take that as a yes. That works really nice. All right. So now watch this. I want to show you one of the most immediate useful things about this. Oh, I don't know where I got that from. So I multiplied some shit out earlier, and I got there. So this is factorable. Does anyone have a method for factoring this? If you do, I want to learn from you. The method we're going to use is using synthetic. I'm going to give us a little bit more information, which later we're going to see where to get some guesses from. But right now, what do you get when you plug a 2 into this? Can somebody plug a 2 into this for me? Let's see what we get if we plug a 2 in. You get 16 minus 8 minus, oh shit, what's that, 72? Plus 104 minus 40. All right, and then what the hell's all that? Well, I know what it's going to be, but yeah, good. What's that?
Zero.
Good. All right. So that's what you get when you plug a 2 in. Can somebody tell me what that means? A factor of this is. What must be a factor of that then?
X minus 2.
Kick ass, right? Let that make sense. Because if this equals x minus 2 times who gives a shit, when I plug a 2 in, that's 0. So I'm guaranteed that x minus 2 is an answer for this. So now we know how to start factoring this, don't we? Did I do it? Yeah, I did. I think I did. Oh, well, maybe. We'll see if I can do the next step. I can now, does anybody have an idea? How do I start to factor this now that I know that? What can I do?
Divide the whole thing by x minus 2.
So the same thing you do if I said, you know, reduce this shit right here, you could do a gesture. If I knew 9 went in, the first thing I would do is divide it by 9, right? To start factoring that bad boy. So I'm going to divide this by x minus 2. I'm going to keep track down here. One factor is x minus 2. So now I know the quick way to do this. You guys do it. Do that division. And you know it's going to come out perfect. You know the remainder is going to be 0. We're guaranteed that already. All right, this is good. Good. Most of what I wanted to. Sort of catch up here a little bit. All right. So if you get the idea, you're done by now. If you don't understand, I don't care how much time I give you. So here we go. Bring the 1 down. Multiply, add, multiply, add, multiply, add, multiply, add. Right? That kicks so much ass. So what do I have now? I've got x minus 2 times, what's this?
X cubed plus x squared minus 16x plus 20.
Kick ass. There's no remainder term, right? So that's beautiful. So it's just, it started on the 4th, now this one starts with the 3rd. Now I still can't do this because what method would you try to factor this with? What would you try? What would be the factoring method you would try on something like this? You could do it. We did it earlier.
Grouping.
Grouping. I love it. And you can quickly see grouping is not going to get you anywhere, right? I like it. So you can all go, thanks, Jeff. But do you notice? Now watch this. I want to point this out. you see how the last number is 20? So the only possible things that could go here have numbers at the end that go into 20. Does that make sense? If they are rational numbers. Okay. All right. Stay with me. Stay with me. So let's try. What do you guys want to try?
10 and 2.
You want to try what again? Sorry.
Oh, sorry. 10 and 2.
Oh, I see. I see. So you could try 10 or 2. All right. So 10 is a factor of 20, and you can very quickly see if you plug a 10 in, it's not going to be 0. Right? You get 1,000 plus small shit ain't going to go back to 0. Right? But now watch this. What do you get when you plug a 2 in? 8 plus 4 is 12. Plus 20 is 32. Minus 32, 0. So 2 goes in again. So you can do this whole thing with 2 again. So one of the most immediate applications of synthetic division is actually a factoring tool to be able to do this kind of shit that we were never able to do before. Okay, maybe. So let me show you this. Let me show you the, we're not done with that, but you basically just keep going, doing that until you go insane. All right.
I have a quick question just before we completely move on from that. All the way
Yes.
back at the beginning, I don't understand how he got -2 instead of, like, say, +2.
Who got, what do you mean -2?
All the way back up at the top, you said x minus 2. Yeah.
Yes.
I understand where the 2 came from. My question is, why is it a -2? Why is it not x plus 2?
So if 2 makes it 0, this is actually related to some problems in the homework. But the homework that's coming. If 2 makes it 0, what must be a factor? What factor goes to 0 at 2? Where would the answer of 2 come from if I had x minus 2 in parentheses, right?
Mm-hmm.
There you go, done. So if 2 makes this polynomial 0, then x minus 2 must be a factor of it.
Still a little confused. Oh,
Right, so
I just want to know why it's a negative and not a positive. Because
it isn't. That's part of the problem. So let me erase. I mean, I know why you're saying it's negative, but it isn't. It's x minus 2. So
yes.
if I factored something and I got there, what are the answers to that?
I don't know.
So how do I get
X
the answer?
equals 1.
I have, let me catch everybody up. So I got a number times a number times a number is 0. The only way that can happen is if that number is 0, or that number is 0, or that number is 0. So they can solve. Add 1, you get
Oh, okay.
And of course, minus 1 is 0. So if I have 1 make something 0, x minus 1 must be a factor of it.
Okay, now I get it. Thank you.
So there are some problems in the homework that say, if you know the answers are 1, 5, and -2, what's the function? Well, you just make it x minus 1, x minus 5, x plus 2 equals 0. Yeah, okay.
Yes,
Like
get it now.
yes.
Thank you.
You're welcome. Let's see. What was I going to do? Oh, yeah. All right, you can just stay there. You're fine. So let me show you this handout real quick, and then I think that might be it for today. Let me see.
Can I ask you a question?
Sure.
So at the very beginning, you plugged 2 into the whole thing. Is the only way to do that just by completely randomly choosing a number?
Sort of. But again, now I can point out that I would try only things that are factors of 40. So I wouldn't try 7. Right?
Okay, so the random number you pick has to be a factor of 40, or whatever the last number is.
It makes sense. I'm going to have x minus something, x plus something, and where's that last number going to come from? Multiplying all those last numbers together. So those are going to be my guesses. Now it's going to get a little more complicated when the first number is not a 1, but we'll get there. Little baby steps. All right. So let me show you. Here we go. Let me make this active. That would help. There you go, buddy. So if you go on to Canvas right now, if you go to Unit 5, you've got that function writing thing we did last time, and then you've got this, long and synthetic division. So I give you an example of long division. Look at that bad boy. And then I give you an example of synthetic division. And then I give you this first problem reworked with synthetic. So it's just a bunch of examples. So you can refer to that as you need, as you get more and more used to how this works. You guys with me? So you got that up there for reference. We are going to be using synthetic division a lot because it's so freaking powerful. Okay. All right, so that's up there if you want to take a look at it. Let me think. Was there something else I want to show you? I think that's it. Yeah, I like it. I think I added some more places to turn homework in. So you get a little further in 5 if you want to. Sweet. And then the quiz, that is on Monday. I said this earlier, but not everybody might have been here. Just to remind you guys, originally it was supposed to be on 5.1 through 5.4. We are going to make it 4.1 through 5.2. So it's going to just kind of go 2 sections back.
Wait, and when is the quiz?
On the 14th, which is Monday, yes.
Got it.
Right there, 14th. Like it. All right. And don't forget about my, if you want to, you can come to these extra office hours, right? So I've always got the time right before class, but then I got those 2 other hours through the week that you can come to if you want to. All right. So we'll say officially class is over for today. If you have any questions, hang out, let me know. Otherwise, you can head out.
Thank you.
Thank you.
Anytime. It's my job. It's my job to confuse you. So
I have a question.
yes.
Which approach would be better, let's say, if you have 3x to the 4th, and then you could just, I know you said you could still use synthetic division, but it would be like a little more.
Wait a minute, let me make sure. So what do you mean? There on the bottom, there would be something? What do you mean?
So like, for example, like if you keep the top the same, for example, x to the 4th minus all that,
Put
if you
it 3
keep it
here?
the same. No, the bottom, the 3x minus 2.
Oh, so here's where things get interesting. This one is relatively easy to take care of, but it's still gross. What makes this 0?
I was gonna say 1.
You add 2, divide by 3, so you get 2/3. That's the number you would put in the penalty box. And then you would start putting 1, -1.
Oh, okay, so I understand now. So you just have to.
So this is what I meant by if you don't have exactly this. If you have a number in front, that's an easy fix, but it makes the math gross. So it's a bit of a trade-off. If something was squared, I could try to factor this and then do synthetic twice for each of the factors. You see what I'm saying? So that's more than you asked, but there are ways to get around it if the bottom isn't perfectly like it's supposed to be. Good.
Okay. Alrighty, sounds good. Thank you.
All right, man. Take care. Sylvia, Melissa, you got there?
I have a question about the penalty box.
Yes.
When we're doing synthetic division, and let's say that equation that we had right there, x squared minus 2, would we put it up as this? The penalty box would be a positive 2. Why is that?
All right, let me make sure. Let me take away this because that's going to make things freaky. Right? Let me see if I can use you one more time. So yeah, so whatever this is, I'm going to put in there what makes it 0. Really, is what I'm doing. Right? The opposite. Yeah. So it's the thing that makes it 0, which is kind of like 2 made this whole thing 0, so that's why that's a positive 2. It's going to be a part of the answer.
Oh,
but
okay.
I think of it as I change the sign on the -2, make it +2, because in long division I have to keep changing the damn sign over and over. So I just do it once at the beginning.
Oh, okay.
So said x plus 3 up here, what would go in there?
Positive 2/3. Oh,
No, if it said x plus 3.
Oh, x plus 3 to go -3.
Beautiful. Kick ass.
Thank you.
Well, I'll see you later. Have a good weekend.
You too.